Alright, number 3 is a really long problem, so I'm going to try to do this as quick as possible. There's the answer. Just kidding. I'm going to tell you how to find the answer. Okay, I will try to do it quickly though. Okay, tank of water, there's the tank. Is a hemisphere with a radius of 5 feet. There it gives you the density of the water. That's important, 62.5. Remember that. Memorize it. Okay, and then water out of the tank. Here we go. Okay. Bright light. This is from the last try. I tried to make this video. I forgot what I was doing halfway through and had to start over. But yes, here's a nice picture of the tank. Notice that, okay, so the radius is 5 all the way down here. So I've labeled the height of the tank from 0 at the top to 5 at the bottom. Why did I do this? Because water at the bottom has to travel all 5 feet to get up. This is, the height is basically what we're going to use as distance traveled for the water in the equation. And it takes that into account. Okay, so what we're going to use to find work is work equals force times distance traveled. Don't confuse little d for big D over here, because we're going to define force as volume times big D for density. Volume times density. Right. So work equals force times distance. And with the force defined, now we get work equals volume times density times distance traveled. It gives you the density. There's a density of water, 62.5 pounds per cubic feet. I've never met anyone with cubic feet. If you've met someone with cubic feet, please leave a comment in the box below the video. Thank you very much. Times volume, which we're going to figure out in a second. And then the distance traveled, like I said, is x, because the water at any given point in here has to travel this x value to get out. If it's up here, it has to travel this x value. It's a variable that changes, so it's x. Volume. Alright, this is where I forgot what I was doing in the last video. So, volume equals the area of the base. This stands for area of the base times height. Right. And so, the area of the base is pi r squared. Here, to get the r in said equation, this is really cool. You draw, okay, so the radius is 5, right? You draw the radius out to one of the lines representing the border of one of your delta x's. Delta x. And then you draw a little triangle here. This is x, because represented by your height over here, so and then your radius is 5, and then you're solving for little r down here, little radius, which is there. And so yeah, you do your Pythagorean theorem, and ignore that too, because that's why I forgot what I was doing in the last video. And that is your radius. Right. Oh yeah, ignore that too again. Mistake. Right. This is wrong also. So, yeah, okay, so, then you say pi square root of 25 minus x squared. Squared. And you guessed it, that cancels out. Times height over here, which is delta x. Alright, so now we have our volume. And I'm going to simplify this a little bit, just for the sake of it. so you're not shocked when I where did that come from? Oh my goodness. Okay, so now we've got our full equation is work equals the density times the volume. I'm gonna try to get this whole thing in here. So equals pi times 25 minus x squared is in the delta. And then I'm gonna just put this x in here because the delta x usually goes on the end. Alright, x is distance traveled, and then delta x. There. And you know what's coming next, because this is calculus, and everything's an integral in calculus. From the top of the tank to the bottom of the tank. Top, bottom. No distance traveled, furthest distance traveled. See the picture? See the equation. Then yeah, you can take all the constants out like this. 25 minus x squared x dx. There. And then alright, yeah. That's it. I don't feel like integrating this. You can multiply everything out, get it into a polynomial, and then split it up into separate integrals and solve it that way. Or you could do it some fancy way using like U substitution or something, which is probably the way you're supposed to do it, actually. Maybe, I'm not sure. Just plug it into Wolfram. Anyways, your answer... Where is it? No, that's not it. Oh, there it is. 30,679.6. Where's my mouse? Yep. Alright, and that's it. Okay, bye.